So, erstmal irgendjemand, der kein Deutsch spricht. Sonst, also ich habe mich eigentlich auf Englisch vorbereitet, aber irgendwie glaube ich, dass hier jeder Deutsch versteht. Or anyone who doesn't understand German? So you? Okay, I think I just do it in English. I mean, everybody understands this, right? So, okay, yeah. Welcome to my talk about Docker. No, it's not. uh, No, it doesn't really get full screen. Okay. Well, who has heard of Docker before, and like in general? Okay, and actually used it, played with it around, and any production use case? Oh, okay, one, cool, at least, yeah. Um, my name is Johannes Ziemke, or most people might know me as Fish. You can find me as Discordian Fish on GitHub and Twitter, and right now I'm working on building Docker's hosted infrastructure, like the Docker IO side and the index. I'll talk about these pieces later. Before that, I worked as a system and infrastructure engineer at SoundCloud. Where like basically the main challenge we had was like scaling the infrastructure to the 10 times growth we had in those 2 years. So what is Docker? It's an open source project written in Go, which is also really developed in public, not like some other corporate open source projects. And it's basically about building and packing and deploying applications as lightweight containers, which are kind of like in VM. And like the basic idea is that you build this static container once and it runs almost everywhere, which means in that case you need a recent Linux kernel, but the distribution doesn't really matter. And for development purpose, it's also possible to run it via a VM wrapper on OS X. So what's the difference to a VM? The biggest difference is that it's really a lightweight container. It shares the same kernel. There's no virtualization involved, so you have basically no overhead over running those things on bare metal. You can share files by using the other difference is like the file system backend where you can share your data across different containers by using stacked images. The grumpy old 60s nerd might argue, who cares? We did this for like since the 60s, where it was already possible to use some containerized thing. But at least some people do, like since .cloud released Docker a year ago. It was like the rewrite of the software they used for powering their platform as a service. And since the release, it's over 10,000 images on the central registry you can right away use. And there are over 4,000 Docker files on GitHub, and we had over 1,600 external pull requests from people all over the world. So at least some people think that's an interesting thing. And I hope I can convince you too. So you might ask, why should you care? And this really depends on what problems you're trying to solve. One common use case, for example, is to test things. Like if you test things, you want to start with a clean slate, and you don't want to accumulate stuff over the last tests. And Docker makes this really easy. So you can with Docker easily spawn up your complete test infrastructure with database servers and everything, and really in seconds, and trash it afterwards. So you can always start with a clean slate. It's possible with VMs as well, but it's much slower. Another interesting use case I wasn't even really aware of when I first started working with Docker and then joined the company Docker is that it's really a great tool also for making things easier. For example, one common use case we see is that people use Docker to provide, for example, students within software environment, which would be otherwise hard to set up. And again, would be possible with a VM, but it's just much easier with Docker and much faster because you have that overhead, and the university has also usually not the resources to have one VM for each student. So it's a really nice use case for this. Another thing is also like using, for various scientific purposes, where you have like I saw some people doing things for bioinformatics where you have those complicated RNA analytic pipelines, which are probably hard to set up for somebody who isn't into information science directly. So that's also a great use case. You can just wrap all this up and ship it to your students or your co-workers and whatever and use it. Or it's also just easy for like running your own blog on stuff like this, especially like if you're concerned with the NSA and Google and you don't really trust this. Docker is also a way to make it much easier to lower the barrier for people to just deploy and run their own services. So the other thing, and that's also my main interest in topic in this topic, is building infrastructures. And let me show why I think that Docker is the right building block to build your infrastructure automation around. But let's quickly look how infrastructures looked before, like in the 90s, where when I say 90s, this is probably true for most corporate big infrastructures up to until today, that they were often proprietary, homogeneous environments where you had often one vendor, and they were vertically scaled, so you just bought bigger machines if you need more resources, which makes things easier. You had release cycles of months. I've been there where you had to wait at least 3 months to get a tiny change in some user-facing UI out there, or even like almost a year to buy a new server and stuff like this. And I think this has changed a lot, especially in the smaller startups, where how you scale your infrastructure nowadays is you split out little services and scaling horizontally, so you end up with much more services than before, and much more like spinning wheels in your infrastructure. And you have also, it's not uncommon to have like several deploys per day to really user-facing deploys. And obviously this makes things much harder to get right. Another difference is that as opposed to the 90s infrastructures where it was often like that there was those huge companies with huge IT departments that were mostly targeting like vertical business, like financial institutes and stuff like this. Nowadays, most people doing infrastructures in this scale are really addressing the end users, and that can be millions of them. So if you start in startup today, whether it fails or not, but your goal is to really reach like everyone out there. I mean, it's all the web-based startups basically. So you need to keep that in mind when you build your infrastructure, that you can get to this scale. So what are the actual challenges? I think it's just the simple fact is just it's incredibly hard to manage infrastructures. There are millions of knobs and switches in your infrastructure you can change, and it will affect whatever other parts of the infrastructure. And I think this makes it a huge complexity, and it's really hard to look at your infrastructure and know like if you change this bit, it will affect that or it won't affect that. So such things are really complicated to reason about, and my thesis is that nobody really can understand those bigger infrastructures, like every part of it. I think it's just not possible. So what is the first thought? The first thought is, let's automate all this. You maybe know that quote, "Go away, or I will replace you with a very small shell script." That's basically what people are doing. And there are a lot of tools for this. Like they all build around this concept of state convergence, where you basically describe what you want and describe how to get there, and the system figures out how to do it. For this, you have to basically change things, and you need to encode that. If you change this, restart that service and stuff like this. And there are various tools for this, like CF Engine, Puppet, Chef, Ansible, Salt. And yeah, the idea is to basically manage all this. But I think it doesn't really solve the problem. It just tries to manage all those things, but you basically, yeah, it doesn't really solve the problem. And the actual problem, I think, is about managing complexity. I mean, it's basically like most informational science is about managing complexities. And if you look at similar problems and how they get solved, like software complexity, we introduce the concepts of modules, classes, plugins, whatever, to make like the things you need to think about smaller. Same for human communication. I mean, you for things you find some concepts and name them. I mean, the cat or nerd or car are just like a name for some concept. And shipping goods, to come back to the topic. Also the same problem. Like in the 100 years ago, shipping goods was really hard because you had those different kinds of transportation, you had different goods, and what they came up with was the intermodal shipping container. They are all the same, and you this container can, you can put it on a train, on a truck, on a ship, and you don't really care about the content of it. So the solution, or the best solution we have, or the approved solution is abstraction. You abstract things so that you don't have to think about all the internals all the time. And I think you can think the Docker containers as kind of an abstracted application, where you have like all your dependencies and all your configuration within that container, so that you either just are concerned with the container and the content and building the container, or you are just concerned with running these containers and you don't really care what's in it. Sure, there's some limitation, like resources it uses and stuff like this, but like that's the basic idea. And since it's also separated from the OS, I mean, that's the point of the abstraction. It can run everywhere. I mean, if it runs on your local machine, it can run on your production system. So that's the promise behind this idea. And since they are that lightweight as compared to VMs and only really wrap the application, and with the VM you get like all the IP configuration you need to think about, and your kernel and whatever, and you usually don't care if you're just about like deploying an application, whether it's your own or some backend services. Docker helps with the isolation so that one container won't affect the other containers running on the system. And this also leads ultimately to a clear separation of concerns, also not only from the technical side of things, but also like from the social side of things. If you're working on your company, if you work in a company which grows really fast and you get constantly new people, it really could suddenly become a bottleneck that like every developer needs to talk to ops where they can deploy their things and what they need to make sure and stuff like this. And this is also something Docker helps, because like as a developer you will like Docker because you really own the container and you don't care about anything else but what's inside your container. You have your libraries, you have your own package manager with your own distribution within it, and ultimately your code, and you don't really care where it's running. So, and the nice thing for operations is that you just care about the container and you don't really care about the content. So you can really focus on just provision your systems with Docker, do resource planning and monitoring, and look at orchestration which means basically where you want to have those images running. And I think yeah, you just need to think about less things than before, and I think it's a great thing. So how exactly is Docker doing this? So basically, Docker is about running commands on immutable, shippable, layered images with a copy and write storage on top to persist like the data you change, and all this in an isolated environment from other containers. And all this is then accessible via REST-ish API. Where it's a command, this command can also be init, so you can also start a full-blown system with all services, but usually it's recommended to be just a wrapper around your specific services because that's usually scales better, but it really is up to you. So first of all, the shippable image. So the image are immutable. If you build them once, they are there. You can just throw it away, but you can never modify it, which makes it easier to think about them. And they are like stacked on top of each other. Like you have, or an image is very multiple layers that are stacked on each other. And you initially start with a Docker file where you defined how to build your image, and it gets built by the Docker builder. And then you can push it to a registry, to a central registry or your own, and pull it from there. So let's start with the Docker file. This is really just a simple text file with few instructions. You start with this from, which basically says on which existing image you want to build your own image on top of. There are some centralized hosted images. You can build your own, or you can say from scratch if you don't want to start with anything. And then some metadata, some commands, but I'll come to those details later. And then you use docker build, the command, to build the image based on this Docker file. You can name it and stuff like this. And basically what it does is for each of those instructions, it creates a new layer. So the apt-get line will basically create a new layer, and this layer contains only what this command has changed. The cool thing about this is if an instruction hasn't changed, you can just assume that it hasn't, that the output hasn't changed. It's not necessarily true in all cases, but it's a pretty good default. So they can be used. So if you are way below, change some line and rebuild it, it will use the cached layers on top, which speeds up building images a lot. And then, yeah, finally you can use docker push to push the image to a registry, either the central one or your own. So in the Docker registry is basically a standalone service which takes care of hosting and delivering the images. It's also an open source project, so you can run your own, supports various storage backends, and there is a hosted platform, index Docker.io, yeah, where you can just sign up to use the central thing if you don't want to yeah, build your own. Another feature which we offer there is a source builds, or called trusted builds, where you can just point it to a Git repository, and it will basically pull that Git repository, run Docker build on it. So it's basically your build system you can use. And the user who want to use your container or your image can also see like exactly which Docker file was used to build it, because otherwise you can't really tell what people built into your image, but that way you can. So then before the image get run, there is also a copy and write storage layer added on top, which provides like the writable layer. And it persists all changes you do to the running container. So you basically have your static image, which gets started, and then everything which happens to this image, you can remove files, add files, and everything that will be only persisted in this copy and write layer. We support different drivers for this pretty recently. So we started out with AUFS, which hasn't that good support by most distributions. I think Ubuntu is basically the only one which has it in the default. So we nowadays also support Btrfs and device mapper, where I would recommend Btrfs. The device mapper is still a bit flaky. Um, so yeah, and with all this, you basically end up with something like this, where you have like your basic kernel, which provides all those things like the file system. Then you have an image on top, which can again consist of multiple layers, and then like your writable copy and write layer on top. So yeah, to isolate containers from each other, we have also pluggable backend. Initially, we started out with using LXC, which is well known for basically that, without all the management around it. But we recently switched to a native library basically. But both use the same things, like the kernel features namespaces and C groups, where like the namespaces are used for isolation by scoping, so that you have your own namespace for things like the PIDs and the mount points, networking and stuff like this. And you have like the C groups, which are used for limiting accounting of resources like memory, CPU. But like the pluggable execution drivers, I would call them, makes it also possible to adopt this for other isolation methods. I mean, Solaris zones, BSD jails are come to mind, but it would be also possible to add like full-blown virtualization if you really need to a complete virtualized machine for whatever reasons. That would be also possible at some point. So yeah, and all this is available via a REST API. So per default, it listens only on a Unix socket, but you can open it as public HTTP or protect it with TLS, client and server authentication. And you can see it like the system's API. You don't really need anything more to utilize the resources your system provides, because you can really use this API for running all your things. You don't really need SSH access. Our developers have no SSH access or anything. They just use the Docker API for everything. But yeah, we're a small dog feeding infrastructure. But yeah, that works. Yeah, missing pieces. I mean, does it solve all the problems we have in our infrastructures? Unfortunately, not yet. It can be used for like the core thing of building, sharing, and deploying your services, but it doesn't address other things that are missing, for me at least, for like my perfect infrastructure. For example, Docker itself doesn't address like things like service discovery or dynamic scheduling of the containers. It just knows about its host for now, and yeah, is there used for managing those things. But you can build those things on top of it. So there are some projects to close the gap to really provide you basically for everything you need to run everything in your data center. There's OpenStack, for example. I'm pretty sure some people have known of it already. It's basically the idea they want to rebuild the Amazon Web Services. And they now support Docker containers as well, so that you don't have the overhead of the full virtualization. But it's Docker on top of OpenStack, and not really something that fits really nicely with Docker. There are also CoreOS or Mesos, for example, also really early candidates. And yeah, they have also different roots than Docker. So the CoreOS, systemd stuff, yeah, whatever. It just that it is also not that great fit. But there's Flynn, which I think is one of the most interesting things. They're also really early, have like 2 developers or something. But they, I think, doing it really right. They provide also host abstraction. That means that you don't really care anymore where to run something, because the concepts of hosts aren't there anymore. You just have one centralized view, and this takes care of running it somewhere, which is also the basic foundation for an infrastructure where you just don't care anymore if any system goes down, because it's just one little piece of your infrastructure. Yeah, and it has also service discovery, distributed configuration, scheduling, everything. It's just pretty early. That's and maybe a word about like the state of Docker in general. I think it can be used absolutely for like the testing use cases or deploying a small application, but there are still some uh, yeah, some issues here and there where why it's not yet supposed to run in production. But I mean, I run it in production, so it works as well. But just make sure that you are willing to spend some time debugging it until it, uh, yeah, until some months go by and we finally get to Docker 01. Let me show you now some things in the actual Docker. So here, that's okay. I hope you can read this. I think I should shorten my prompt even more. That's better. Let's save this one line. Okay, so yeah, let's start with the basics. Docker run takes an argument and an image where you want to run a command on, and the command can be really simple like this. Oh, great. Yeah, it's always the same, right? Yeah, looks yeah, that's the reason why we replaced LXC, because like depending on the right LXC version and stuff like this, it's really and I had it for another reason, still using uh, the LXC driver, but let's uh, yeah, it wasn't up yet. Still takes a It's still starting up and loading like the old containers and stuff like so. It takes a few seconds and then it should. Okay. So yeah, it works. So basically, what we did is run a new container based on the Ubuntu image, where we didn't do anything else than echoing "Hello World." So so you can directly run commands like this, or you can start an interactive shell. You provide those flags for keeping your std in open and stuff like this, and then you are in the container. So if you do ps, you see there isn't many things running. So we are obviously in an isolated environment somehow. Um, let's start some process here. So we see pit 9, and let's see. See it? Oh. Hmm. Where's my window? Okay, I hope this worked with screen. Okay, it doesn't. Well, yeah, I basically just wanted to show you that it's on my host system has a different pit. I can. Oh, let me just start a new terminal. Okay, let's. So yeah, there's the sleep running, and this had this PID, where in the container it has this PID. Okay, so uh, in case you didn't believe me that this actually works. So the same is for the MNT namespace, which isolates the mount points. Those are also only the mount points within my container. But yeah, it gets a bit messy there. Yeah, same for network addresses. That's like only the local addresses in the container, and on the host system, I have all kinds of interfaces. You see those? You can't really see it. It's ugly. The VETH interfaces, those are per container interfaces, which use the network namespaces to move them basically into the container. And those are like peer-to-peer interfaces to connect the containers to each other and to the host, and they are all what's going on? Okay. Yeah, right there. Yeah. Okay, yeah, good. Then we can skip that. So you might think, yeah, what can you do with the container and what not? That, for example, shouldn't work. Yeah, or operation not permitted. No. Okay, so you can't, for example, set down your interface. So the privileges you have in the container are limited, not only isolated. Yeah, to avoid like damage caused even by root in those containers. So you get some safety on top of it. But to be honest, it's really right now a deployment feature. I wouldn't really consider this as a security feature because I mean, it's pretty new technology, all the LXC and container stuff. So although we limit it, and there shouldn't be an easy way to get out this container because we limit those things. Yeah, it's to me at least more about like isolation and deployment than about like security. So on. So, but if you need for some reasons more privileged, you can pass a flag here, which is called privileged. Yeah, a double dash, but whatever. And then you can also set down your interfaces, and it won't work anymore. So another important thing which some people get confused about is the difference between images and containers. If you run like Docker run Ubuntu touch test, you might expect that this should show you something, but it doesn't, because what we did was creating two containers based on the Ubuntu image, and the first container contains now this file I created, and the other doesn't because it's separated containers. So you can see this. You can see the containers by using Docker PS. -A shows also the exited containers. So. Okay, those are the two containers. Yeah, it's not that readable. But yeah, basically here you see the command. This was the ls, and this was the touch command, and they resulted in two different containers. So what you could do now is, for example, commit this container to a new image. So the Docker commit command, takes this copy on write layer on top of the image, and basically makes it an image layer so that you can use it again. So you can now commit it and then name it somehow. So now you created a new image which includes this file, and you now can run commands on this image. and you should see, right, the file we just created. So we basically took the container and built a new image with it. So this is one way to building image. So you can really do this. You can spawn up a new Ubuntu container, install all your stuff with apt-get and whatever you want, and then commit it and have an image which contains exactly this. And it will, if it ran on your laptop, it will run on your production service. But since it's not that nice reproducible, we have this Docker builder, which is kind of noise. Where am I? So I'll just do it like this. That's enough. So for this, so here we have a Docker file, which is basically doing from Ubuntu, setting some metadata, running an apt-get and an install of Cowsay, and then sets an entry point, which means this will be run by default and the command parameter is basically the default parameter. So if you do docker build t like this, it now will build this. Gladly the steps were cached because I'm running out of time, I think. So, and now you can use this image like this. And we used this as the default parameter. So if we do something else, it will run like this. So the entry point will be the same and will also always point to Cowsay, which makes sense. Like if you have a service or something, then you can point it to this service. I had a few things. Let me maybe. Yeah, I think the most other things can be just read up in the docs. There are some other commands like exposing ports and linking containers together, so you have a nice way of integrating like your backend and your front end and stuff like this. But that can be read up in the documentation, or just ask me later if you are still interested. So I think now I have like 5 minutes for questions. So has anyone questions?
Thank you for your nice introduction to Docker. So anyone questions?
I'm Veliber from Novi Sad. I heard about Docker a month ago, and I'm in a cloud with many things I'm working in Novi Sad. And this is a great thing, which I'm not sure how this really works. But a few questions I have in my mind. If you have maybe 3 or 4 Dockers and everywhere is MySQL, and you need somehow to communicate between who is doing the routing, because it's independent from kernel and from drivers, right?
Yeah, that's exactly one of the missing pieces I talked about. I mean, you can just run your MySQL container and expose it on some port, but you want your clients to somehow find it automatically without having to hard code your IP addresses in there. And that's something that's still lacking somehow. I mean, there are like the concept of ambassador containers, where you basically use a little container to do this bridging around, and then you can use the Docker native links to connect it locally on the system. But yeah, that's definitely something that isn't properly addressed right now. You can build those things with, often people use etcd for it, which is like a consistent data store, where you could have just your code to write your I'm here and then fetch this information from your clients and stuff like this.
That's the part, somehow the part of the second question. How is mounting done? Mounting some NFS problem. somewhere on network, and they need it for that particular container.
So there are two ways. A normal container isn't allowed to mount anything because the limited privileged. It would be probably possible to mount it outside of the container and then use a bind mount, which is a feature where you can just mount like files from outside the Docker container at some path in the Docker container. So that would be an option.
Okay, that require pretty big knowledge about everything. Okay, thank you very much.
The problem is also NFS is something that doesn't really fit nicely into all this because
okay, that's just
it's
example.
a really low level protocol.
Thank you very much.
Thank you.
Next question, please.
Hi. I've heard from Docker, but I haven't used it now. No time for testing. But we have some own self-written solution in shell script, as you said, to test things in containers. We use ZFS. Is Docker, is some integration of ZFS on Linux planned?
Not that I'm aware of, but if you want to write on okay.
Okay. Thanks.
Yeah, I mean, it's really, really fast-growing ecosystem. It's really impressive that I constantly learn about new things because somebody did them.
Okay, thank you.
More questions?
My question is, what parts of the underlying operation system does a container see, or is it completely isolated from the operation system?
It's completely isolated, so it doesn't see anything. You can even basically run Docker as your init because you don't depend on anything on your system either. So.
In what way is it more lightweight than a traditional VM?
Well, the biggest difference is that you don't do any virtualization. You use those kernel features, which basically provide a way with almost no overhead to isolate those things. Just basically offsets and like the PID namespaces. So that's the big performance difference. So it uses the same kernel. Or otherwise you can't use a different kernel in your container than on your host system. But yeah, that's the thing. That's why it's that lightweight.
Okay, so it still carries an operating system with all the files, but it doesn't use a different kernel.
Yeah, especially like all depending on the virtualization technology you use. Basically, everything you do on the system will get at some level virtualized, and you're running on virtualized hardware, and this makes things that slow as compared to bare metal. And with Docker, there's really almost no overhead. If you look at running benchmarks in the container or bare metal, it's really almost no overhead. The only thing that does a bit overhead is the software bridge for the networking, but you can even get around this by manually managing the interfaces from outside. So if you really need like tens of gigs throughput, then that would be the way to go.
Okay, thank you very much.
Unfortunately, we are out of time. We thank you, and I think we should give him a warm applause.